Okay, so today I'm going to talk to you about mobile phone data, temporary migration, and climate anomalies in the context of a Sahelian country, which is Senegal. So yeah, let's jump right in. So I wanted to show you this map firsthand, as it hopefully illustrates the fact that we can capture temporary or short-term movements with mobile phone data with that level of granularity. So we have here over 900 locations across which we can calculate the stock of temporary migrants for any period of 15 days and over a period of 3 years. So normally this is an animated map. So if I click on it, it gets animated, but it doesn't. So you will have to believe me. But technically, it allows you to visualize the evolution of the stock of migrants over a period of 3 years at that level of granularity. So it's by exploiting the fact that people use their phone quite frequently that we can measure their movements across space and over time, and hopefully gain new insights into these types of mobility that is largely understudied given the lack of data on these types of movements. So a large fraction of the literature on migration focuses on permanent movements, on these kind of long-term movements, but here we're interested in temporary movements of at least 20 days. So I'm going to tell you about the mobile phone data, the raw mobile phone data that's underlying these maps, and the methods that we have implemented to actually extract migration information from these raw data that say nothing by themselves, right? And hopefully, if I have time, I will show you some results on how we exploit these phone-derived migration estimates to better understand how people react to climate anomalies in terms of their temporary migration choices. So this is the type of data that we use that is called call detailed records. So you probably have seen that in the literature already. This is basically what a call detailed records dataset looks like. So we have a column that gives you a unique identifier for a user and some information every time the user makes or receives a call or a text. So we have the timestamp of that call. We have an identifier, a unique identifier of the phone tower that processed that call. And all of those towers are actually geo-referenced. And that's what allows us to kind of infer a trajectory across space and over time for each of those individual users. So in this data set that we're using in Senegal, we have approximately 100 billion records over a period of 3 years for approximately 10 million unique users. We don't use the full data set. There's a lot of noise in there. So we just select a subset of users that are seen frequently and for a long enough period of time that we can actually identify these types of short-term movements. There is a general objection that is made or a limitation that is put forward when using this data is it's the one of representativeness. So it's obviously a non-random sample that does not rely on a rigorous sampling frame. So that's what we find as well in trying to characterize to the best of our ability this data set and those users. We find that it's a non-representative sample, of course, but it's not wildly biased. And surprisingly, it represents pretty well some subsections of the population, in particular men. So we implement some correction methods that allow us to take into account this disimbalance in terms of the distribution of users between urban and rural areas. And we get a fairly good representation of the overall population. So then in terms of migration detection, we take those raw trajectories and they're all different from each other. Some people are seen very frequently and then not seen for 5 days or 10 days. Others have different types of trajectories. So we implement a clustering method that is largely based on a paper by Chi and Carter, and which I'm going to illustrate with those few sketches. So we look at, so you have to imagine this is a hypothetical trajectory for a user that is seen across 4 locations, and we'll look at these trajectories from a macro perspective. And what we see is that this user is mostly seen in this location A that we're going to define as his home location. And then at a more meso level, we're just going to abstract from the very short-term mobility events and see that there is 3 such mesosegments. And we're going to overlay these 2 things and say, well, this is a mesosegment that is not at the home location of that user. So we're going to identify that as temporary migration if it lasts for a minimum duration that here we define as 20 days. I'm just going to show you a couple of things about the temporary migration profile that we've put together. So we find that temporary migration flows are large in the country. Over 11 million migration events of at least 20 days over a period of 3 years. We find that over 30% of the population has an event of at least 20 days in 2013. Of course, this rate decreases with the minimum duration that we impose. And then I just want to show you. Okay, the link don't work, but that's okay. I can show you in the discussion later. But we find that there's basically a large interconnectedness between rural and urban location, a lot of rural to rural flows, rural to urban, urban to urban. There's large spatial disparities that allows us to see that there is more migration rates in very remote locations compared to cities. And there are clear seasonal patterns with large migration during the rainy season. So now with the time that I have left, I want to show you this application that we've made, and we've asked this economic question. Well, we see, you know, we're in a context in which we see a lot of migration during this rainy season. So we've got some kind of regularity in the temporary migration patterns, but the question is, do people react to the fact that some rainy seasons are very good and some are very bad? And is there variation around these trends? So we pair these temporary migration estimates with satellite-based precipitation anomalies, and we try to understand to what extent people respond to those anomalies. So we estimate some regression models, the nature of which I'm not going to bore you with. I'll just jump to the results. So this is the first set of results where we investigate the impact of the conditions at origin locations on the response in terms of temporary migration. So this graph, what it tells you is over an agricultural year, what happens if you have more precipitation is that you will have more migration between the months of September and November, which is basically the harvest season. And this kind of effect persists for the rest of the year and until the next rainy season. So we have a positive linkage between precipitation and migration choices. And then the other way around, if we consider drought conditions, there's going to be less migration during the harvest season and during the hot season, which is from February to May. But now, an important limitation of this kind of model is that it doesn't account for conditions at destination. And this is something that we can actually do given the granularity of our data. We know where people go, so we can measure precipitation over there and understand to what extent precipitation at destination acts as a determinant of the level of attractiveness of those locations. So that's what we did, and we can see that when we take that into account, the conclusion is kind of reversed. So the effect at origin is the same for the harvest season, but then for the rest of the year, we see that if there is less precipitation, there's going to be a higher propensity to out-migrate from that location. But the conditions at destination remains positively related to their level of attractiveness. So I'll just conclude by saying that mobile phone data allow us to gain new insights into an understudied type of human movements, which is short-term movements. We find that temporary migration flows are large and ubiquitous in Senegal with significant seasonal variations. And finally, we find that temporary migration clearly responds in perhaps surprising ways to rainy season conditions, and especially from rural areas. Thank you.